All right, today we are talking about congruent figures, specifically congruence and triangles. So we've talked about congruence before, congruence meaning the exact same size or shape. And that's going to be the same thing with our congruent triangles that we'll talk about here in a little bit. But any two figures can be congruent. Any two figures can be congruent if they have the exact same shape and same size. I should probably turn these off. These two triangles are in fact congruent. We've measured them as such. So let's go ahead and give these triangles a name. Let's label each vertex of both triangles. For whatever reason, I end up doing alphabetical order a lot. So we've got A and B and C. And then let's do D and E and F. So let's mark up the sides of these congruent triangles that have the exact same size. Well, BC is the shortest, and DE is the shortest, so each of them are going to get one hash mark. AB is the middle length side, and EF is that corresponding side. And AC, clearly the longest, looking kind of hypotenuse-ish, though I don't know that's a right triangle officially, so I can't say that for sure. But now we can make a congruence statement about these two triangles in which the order of the letters is really important. So we want to make sure that the order of these letters indicates which sides actually match up. So let's say we talk about triangle ABC is going to be congruent to triangle, let's see here, ABC. So we went through the one with 2 hash marks first, and then through the one with 1 hash mark. So in our other triangle, the one with 2 hash marks, like AB, will be FE. So we went A, B, C. We're going to go F, E, D. This is our congruent statement in which the congruent parts match up. So we'll have segment AB is going to be congruent to segment FE. We've got segment BC, that was our short guy here. That's congruent to segment ED, that's our short guy here. And then we have segment AC. AC is congruent to FD. FD. Cool. All right, let's circle the figures that look congruent, meaning the figures that have the same shape and the same size. Well, they all, no, not they all. These guys, at least in A, those are all squares, but that one's too small. The two squares are going to be congruent. And then in B, they're all triangles, but these are the ones that are congruent. They have the same shape. Cool. Moving right along, checking out number 2. The triangles drawn below are congruent. Write the congruent statement for the triangles. So first we got to figure out which sides are going to go together. It tells us they're congruent. So let's see, we've got JP, that's the shortest side. And AC, that looks like the shortest side over here. PL, second shortest, is going to go with CB, which means JL. And AB, going to go together. Cool. So we can write a congruent statement now. triangle, doesn't matter which order we go in, just matters that the letters, the vertices match up. So let's do JPL, triangle JPL is congruent to, so again we went from J to P, which was our shortest side, from P to L, which was our second shortest side. So shortest side AC to CB, triangle ACB. You guys are doing great. This is amazing. Nicely done. Flippy flop flop floop to the back. Got it. Line that up straight. Cool, so now let's use what we know about congruent parts of congruent triangles matching up to find the values of x and y, since we know these triangles are congruent to each other. Actually, you know what? Let's back up for a second. We know even more things are true in number 2. That'll be helpful for the next one. So if we've got triangle JPL is congruent to triangle ACB, we know that J is congruent to A. This angle here, J, is congruent to that angle here, A. We also know angle P is congruent to angle C. Let's give them 2 loop-de-loops. And we know angle L is congruent to angle B. These are different ways to show angles are congruent. We just got to make sure they have the same markings, so those markings match up. So J is congruent to A, P to C, and L to B. And that was all out also based on the order of these letters. J and A, P and C, L and B. All right, cool. So now let's go back to this guy. All right. Find the value of x and the value of y if we know that triangle ABC is congruent to triangle DEF. So we know angle A is congruent to angle D. Angle A is congruent to angle D. And we know congruent means has the same measure. So we know 5x plus 2 equals 87. We can solve that for x right now. Let's subtract 2 on both sides. So we've got 5x equals 85. Awesome. Divide both sides by 5. So we get x equals 5 goes into 8 one time. Remainder 3. 5 goes into 35. 17 times. Whoo, baby. Looking good. Look real good. Okay, cool. All right. We also know that angle C is congruent to angle F. Angle C is congruent to angle F, which we don't know yet. Huh. Well, we also know B is congruent to E. B and E are each going to get 3. So those guys are 42. So that is 42 degrees. And we know that all of the angles of the triangle must add up to 180. So 87 plus 42 plus 3y equals 180. 87 and 42, 7 and 2 is 9, 4 and 8 is 12, plus 3y equals 180. Let's subtract 129 on both sides. Of course, it's only fair. Y equals, well, we're going to have to do a little borrow action. 10 minus 9 is 1, 7 minus 5. Just kidding. 7 minus 2 is 5. Excellent. Divide both sides by 3 to get that y equals 5 goes into 5 once. Remainder 2. 17 strange. Very, very strange. But that's what it is. Yeah. Okay. Look at you, solving triangles, knowing what's up. It's good stuff. Moving right along. Theorem 4.3, the third angles theorem. I bet this is about the third angle, probably in a triangle. Yeah. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. Let's mark this diagram up. You know what? Let's say triangle ABC pretty much looks like and is congruent to DEF. Let's make this official with some markings. This means A and D are congruent. B and E are congruent. So by default, C and F must be congruent. There is no other way. There's no other way because they all have to add up to 180. So if A plus B plus unknown equals 180, and D plus E plus unknown equals 180, and these guys are the same, that third angle is going to have to be the same. There's no other way around it. So let's do an example to test our knowledge of the third angles theorem. Find the value of x using the third angles theorem. All right, I see that L and S are congruent because they each have one arc. So let's put 65 degrees over here. I see that N and R are congruent. So I could put 55 degrees here. I know all three of these are going to add up to 180 degrees because that is how many degrees are in a triangle, ladies and gentlemen. Let's do a little solvey, mathy. 65 and 55 is... Okay, well that's like 60. 60 is 120 plus 30 is 150 plus 2x equals 180 minus $1.50 on each side. So 2x equals 30. Divide by 2. So x is going to equal 15. And we said, just double checking here, 55 plus 65, that was like, if I gave that 5 over to that guy, that would become 60, and 60 plus 60 is 120. So 120 plus 30 is 150, and 2 times 15 is 30, and 30 plus 150 is 180. All right, I'm into it. Believe it. Done. Cool. Because we got some extra time, let's write a congruence statement about this triangle and then say all the parts of this triangle that are congruent to each other. So we've got triangle. Doesn't matter again which order we go in. Let's do LNM is congruent to, well, who was L congruent to? S. Who was N congruent to? R. So M must be congruent to T. Now, again, let's write all the things that are congruent. All the parts that are congruent in this triangle. So, we've got angle L is congruent to... okay, that's fine. Angle L is congruent to angle S. Angle N is congruent to angle R. And angle M is congruent to angle T. That's all the angles that are congruent. Let's check out the sides. We've got LN. LN is going to be congruent to, again, these are the first two letters over here. So it's going to be congruent to the first two letters over here, SR. Notice we're putting our segment bars on top because they are segments. We've got LN M, first and third, congruent to